starting the intro to inequalities. Now in inequality, which is similar to an equation, instead of having a solution, an inequality has a solution set. Which, when I say solution set, that means it has a group of numbers that it can all be or can make the solution or the inequality work. It's a big group of numbers. We're going to talk about how we can show that group of numbers today. All right? But before we get to that, I want to start by talking about how we know if something's an inequality. There are 4 signs we use when we do an inequality, right? If I have the sign that looks like this, this is less than. That means the solution set is any number smaller than that. If we have this inequality sign, this is less than or equal to. All right, so it's anything smaller, but it can also be that number you're at. This sign is greater than. And then, of course, we have is greater than or equal to. Oops, I got to put the line under it for or equal to. Oh, yes. All right, so in this case, I want to talk about a couple of things. Now, to show solution sets, we are going to do it 2 ways. One way, the way you already know, is by graphing. And when you graph an inequality, that goes on a number line. The second way, which is going to be the new way that you haven't learned before, is called interval notation. I'm going to try. So let's start with the graphing one, right? We all good? Let's review graphing because you already know that one before we get into the new stuff. So when we talk about graphing, I'm going to draw my little line across right here. When we do graphing, I want to remind you that if you have a less than or greater than sign, that is an open dot. If you have less than or equal to or greater than or equal to, that is a closed dot. The one thing that I'm going to insist on in this entire chapter, and you guys will see why in a minute, is that our variable must always be on the left. All right, so let's just look at a couple of these, which I know you have done before. So, for example, if I have x is less than 2, on a number line at 2, because it is less than, that is an open dot. Then if you are doing less than, that means it's everything smaller than 2, so we draw a line that direction and put an arrow on it. Do you notice that your arrowhead and your inequality sign look exactly the same?
Oh, I always thought, to get me past through 7th grade math, I always thought it was the opposite. Like, it goes the other way. You know?
As long as we have the variable on the left, this works every time. So if I had, let's say y is greater than 4. Let's go, come on. enough. All right, if I have y is greater than 4, 4 on the number line, because it's greater than, that's an open dot, and it's everything bigger than 4, so it goes to the right. And again, look at my arrow. My arrowhead and my inequality sign go the same direction. They look the same, right? Let's say I have k is less than or equal to -4 on my number line at -4, because it is now less than or equal to, it has that line underneath it, is a closed dot at -4, and it goes to the left. It is less than. And again, look at my arrow, look at my inequality sign. They both point to the left. Let's say I have w is greater than or equal to 10 on my number line at 10. Because it is greater than or equal to, it is a closed circle. That means that it can equal 10 and anything bigger than it. And again, you'll notice my inequality sign points the same direction. Right? So when I say that it's a solution set, it means that it's all the numbers all the way up to 2. Or if it's a solution set, it's all the way up to and including -4 if it's a filled-in dot. Do we all understand that part? So we remember doing this before, correct? Okay, so let's get to the newer stuff. The stuff you've not seen before. Let's talk about interval notation. Interval notation is actually going to give you, or let's say shows, the solution sets. All right? What it is if you have less than or greater than, which is an open dot, you are going to use a parenthesis. All right? Whether it's on one side or the other. If it is less than or equal to or greater than or equal to, which is a closed dot, where the closed dot is, you are going to do what we call a square bracket. Now, when it's a parenthesis, that means it goes all the way up to that number but doesn't include it. When it's a closed bracket, that means you can include that number. All right, so if I have, let's say I have x is less than 4. We'll go back to that one. On my number line at 4, I have an open dot. This goes to the left. It is less than. If I was writing the interval notation for this, as I look across or read it across left to right, I come to this arrow first. That arrow represents the numbers at -infinity. And it goes all the way to 4, and it's got an open dot, so it's a parenthesis. So if I had y is less than or equal to 7, which on my graph at 7 would be a closed dot, and it would be everything smaller than 7, right? My interval notation for that, again, as I'm going across my graph, starting at my arrow, I start at -infinity, I go to 7, because it's a closed dot, it's a square bracket. Right, because you can never stop on infinity, right? Or -infinity. Since you can't stop on it or include it, it's got to be a parenthesis on infinity no matter what. Okay? So what if I had, let's say I have x is greater than -2. On my number line at -2, I have an open dot, and this goes which direction? Goes to the right. Very good. This is greater than. It goes that to the right. So my interval notation, as I'm going and reading it across, I first come to this open dot, which is a parenthesis at -2. Then where does my arrow go to? Infinity. And can I stop on infinity? So it has to be a parenthesis, because we cannot stop on infinity. All right, let's do this one. Let's say I have y is greater than or equal to 12 on a number line at 12. Is this an open or closed dot? Closed. Very good. Closed dot. And this one, it's greater than, so it goes to the right. Then my arrow, my inequality is the same. The interval notation that represents this. As I go from left to right, the first thing I come across is this closed dot, which means I have a bracket at the number 12. This goes all the way with that arrow, and that arrow again goes to infinity. And you can never stop on infinity, so it's a parenthesis.
How come it's not -12? Like, oh, it was -2. Oh.
Because that's what the number was.
Oh, yeah,
Okay?
okay.
Now, so an interval notation means any number that falls between 12 and infinity all work in that solution. Or all work as a solution.
And the bracket just goes next to the number?
Yep. Yep, if it's a closed dot, that's where you start. All right, so are you guys ready to try some examples of what it's going to look like on your worksheet? Here we go, example number 1. And on your worksheet today, this is what you are doing for 1 through 10. The directions are going to ask you to graph and write the interval notation. For, let's say we have x is greater than or equal to -1. So here's my number line. At -1. Do I have an open or closed dot?
Closed.
Closed. Very good. How do you know it's closed, Madison?
Because it's has that little line, you know?
Correct. It's got the little line underneath it. It's greater than or equal to. Now, if it is greater than, that inequality sign's pointing which way? It's pointing to the right. So that's why we're going to draw our arrow is going to the right as our arrow on the end. Yes.
I kind of like to think of it almost as if like gators, like because the inequality sign is like an alligator and the arrows.
Yeah, we need to put little teeth inside.
Yeah. See, we're in high school now, though. We got to kind of decide that we're going to take it a step up. Yeah, maybe. All right. So on this one, once I've drawn my graph, now I have to do my interval notation. My interval notation, first thing I come across is this closed dot. So what do I have? I have a bracket for the closed dot, a -1, because that's the number I'm at. And where does that arrow go? Infinity with a parenthesis. All right, let's try another one. How about example number 2, still part of the same section. All right, we're going to graph and write the interval notation. All right, let's say I have W is less than or equal to -5. Here's my number line at -5. Do I have an open or closed dot? Good. It's a closed dot. Is this going to the left or to the right? Good. It is going to the left. It is pointing this way. Bless you. Again, you'll notice my arrow and my inequality look the same direction, right? Now I have to write my interval notation. This time I come across my arrow first, which means I start at -infinity. And then it keeps going all the way to this closed dot, which is at -5 with a bracket. Exactly.
Oh, I wrote the other way around.
It's got to go from left to right. Okay? It's kind of like being on your number line. We start at negative infinity and we finish at positive infinity. Okay? All right. Do you guys need another example like that, or are we doing okay? Yes, Jackson.
What if, so like, if it doesn't have a line, if it's just less than, you wouldn't say -5, would you say -4?
No,
No.
because it could be -4.99.
Okay.
It's everything up to 5.
Okay.
Okay, great question. All right, here we go with example number 3. Example number 3 today is going to cover 11 through 16. 16. We'll see. Right, maybe not the, right, inequality and interval notation if you're given a graph. So let's say I give you a graph on your paper. Maybe it looks like this, -2, -1, 0, 1. And you have a open dot, and it goes to the right. So first we're going to write our inequality. Start with any variable you want. I don't care what you use. Which, T? T. We'll go T. All right. Remember that my inequality sign is the same direction as my arrow. So this is greater than. Is it an open or closed dot? So that means it's just greater than, right? And it's greater than what number? Perfect. Okay? Interval notation. Jackson, can you do the interval notation for me?
Let's see. So you start from left to right, and you first see the dot and 1.
Okay.
Parenthesis 1.
Good.
And then, the comma, just infinity.
Yep. And then what do I put on infinity?
Parenthesis.
Perfect. Very good. All right.
Thank you, guys.
Underneath that same example, we'll do one more, and I'll get you your worksheet.
Yay.
Let's say we have, let's go 2, 3, 4. We have a closed dot here, and our arrow goes this direction. All right, so again, we start with our variable. Always start with your variable. My inequality sign, it is going left. It is less than. Again, same direction as my arrow. It does, yes, it is equal to. How do you know that? Because it's a closed dot. Very good. And it's closed on what number? Perfect. Now we got to write the interval notation. Who wants to volunteer to do that? Go ahead, Beck. Good. Uh-huh. Perfect. Very good. All right. So does anybody have a question how this works today? If it's an open dot or if it's less than or greater than, then it's a parenthesis. If it's a closed dot, it's a bracket. Okay?